Good morning, everyone. Welcome to Motion That Matters. I'm Jerome Pitts. We're launching a channel today, as well as a website at motionthatmatters.com. A little bit about myself. I'm not a scientist. I'm not a doctor. Just an individual who has some information that I'd like to share. These are my opinions and my thoughts, and we'll get to know each other as we go. A little bit about the Healing Center, another video. But this is Motion That Matters that is being hosted by the Healing Zone. So, a little bit about the channel. What I hope to do with this channel is to break down some very complex scientific topics and oversimplify them for the benefit of others to understand. And hopefully we'll disassemble some of the scientific concepts that are currently prevailing in our mainstream science. And I had invited an astrophysicist to debate me on a problem called the galactic rotation problem. And I say, what is that? Well, there was a problem. Back in the mid-70s, a new astrophysicist, her name was Mrs. Rubin, first got to sit at one of the big boy telescopes, and she did a study of spiral galaxies. Now we're going to talk about spiral galaxies and what she did. But first I want you just to take a look at an image. There we go. Now, this looks like a recognizable image. Some might say this is the infinite loop. No matter how I turn this image, some might say it looks like an hourglass or the number 8. But this is a recognizable image. And no matter how I turn this image, you're going to see that pattern, or we might call it a structure, if you will. So now back to Vera Rubin. She was looking at spiral galaxies. And what she did was, using a tool called redshift, she was looking at some of these outer stars, and for the sake of simplicity, some people don't realize that these stars are suns. So, and this is a very big distance here. We're talking about hundreds of millions to a billion stars in these structures here. So, back to Vera. She was using a tool called redshift to measure the motion in some of these outer stars. And then she was taking those and comparing them to structures here in the center. And what she encountered was a flat curve. There was no relative change in motion from this point to this point. So she studied 6, and then she tried to publish a paper. I'm not sure exactly how that went down, but when it got to peer review, there was a real problem because they just couldn't believe that her data was correct. So there was a problem. Next steps in, Kent Ford, Vera Rubin and Kent Ford did another study, and they studied in total 60 different spiral galaxies. And I don't know why they had to study so many, but they did, and they came back with the same data. Kent Ford had just developed, an inventor who had just developed the most sensitive spectral analysis equipment to date in the mid-70s. So her standings stood. So what was the problem? Why was this a big issue? Well, if you have ever rode on a merry-go-round, for instance, if you're in the center of a merry-go-round, it doesn't matter how fast you rotate it, you can stand there and not even hold on. But if you move to the outer edge, if you're here, no problem. You can move out to the edge of the merry-go-round. The inertia, or what we used to call centrifugal force, is literally trying to throw you off the thing. And that's what they said the problem was here. As this thing turns, that these outer stars should be thrown off. Thus came the search for dark matter and dark energy. So, and I believe that was a magician's sleight of hand myself. They're proclaiming that unless there was a lot more mass here, there's no way there would be enough gravitational forcing or attraction to maintain the position of these stars. They would literally be thrown off. Now, I think that what is quite obvious to you, and I hope it's obvious to me, I hope it's obvious to you, that no matter how I turn this object, the only way that you're going to see the structure is if the whole thing turns together. So if that is the case, why would you need to take a look at 60 different galaxies to determine that this thing has to be all turning at the same rate? Now, why is that a problem? Well, because of our previous theories, general relativity and Newtonian mechanics, and our understanding, if we were to look at the way our planets and the solar system are moving, we have the center ones moving faster. In other words, in the center, when we look towards the sun, excuse me for just a moment, we see Mercury orbiting fast in the center. We see Venus moving even a little bit slower, and then Earth moving slower, and then Mars. But anyhow, what happens is, if there's that kind of motion in a spiral galaxy, we've just broken all out. It wouldn't be visible like it is to us when we look at these objects. These objects are light years away. And as they have looked at 60 of them in this one study alone, each one is like a timestamp. So the further out it is, the further back in time, or if it's inward towards the galactic center, or the universal center, earlier, and away from the universal center later. So these are like timestamps. We're looking at different time periods, and we're always seeing this structure complete. Now, why are we not talking about what is this structure? What is this structure that we see and seem to ignore in our scientific community? Well, this is a pattern that's known as the phi spiral pattern, and it's prevalent throughout all matter. And for that matter, if I would have had my artist, this is a volunteer creation, avoiding copyright infringement, by Alyssa, and thank you, Alyssa, or a Nautilus shell. It's prevalent throughout all these are organized energy systems. That these energy systems are the key to everything. I respect your time and I don't want to keep you long. That this motion that we saw here does actually translate to the way our planets move around the sun. And that'll be in a coming video very soon, and we'll relate the motion that is seen here to our planets. And we're going to start at the galaxies. We're going to work to the planets. And we're just going to go deeper and deeper and oversimplify much of the science that we've been sold. And we're going to analyze it, and we're going to break it down, and hope you enjoyed, and welcome to Motion That Matters. Have a good day.